Hello dears, we continue. In the previous lesson we discussed example 3, now we discuss example 4. Book is Physics for Scientist and Engineer, Giancoli. Okay, so example 4. So capacitance of two parallel plate wires. So we have two wires. So this dot sign shows that the wire is out of the page, mean the two parallel wires that are out of the plane. So basically, for example, here we have this wire and another wire, two parallel wires. We have two parallel wires, and basically these dots shows that the wires are out of the page. Okay, out of the page. And so we need to find the capacitance of these wires, the capacitance per unit length of each of the two wires. So in order to find the capacitance per unit length, we use the formula for, we use the previous result. So we first we use the previous result of electric field intensity E at a specific point. Suppose there are two wires, so these dots shows that the wires are out of the plane, so they are parallel to one another, and so the separation between the wires is D. Okay, now we use the concept of electric field intensity in order to find the potential. Number one step is to find electric field intensity E. We find electric field intensity E, then we find potential V by using formula E dot dl. Then we find capacitance Q is equal to CV, C is equal to Q over V. So basically capacitance is Q over V. V can also be found by using integral of E dot dl. So we find E. First we find E, then we find V, then we find C. Okay. So we use the concept that the electric field intensity, we know the formula of electric field intensity at the distance x from any one of the plate. Suppose on the left plate we have negative charge that is stored, on the right plate we have positive charge stored. So that the from negative to, suppose this is a point, any arbitrary point P. So this distance is distance x from the plate minus Q. This distance is x. Then the distance for between plus Q and the P point is total distance D minus x. Okay, so the intensity, total intensity, we use our previous result of the electric field intensity E is equal to lambda over 2 pi epsilon naught into x for the minus Q, plus total field intensity for the plus Q, that is lambda over 2 pi epsilon naught D minus x. Okay, so why we add this? Because the total intensity, net intensity at point P is the sum of two intensities. We use addition principle or superposition principle, so that at point P we know that the electric field intensity due to negative charge is towards the left side. So E1 is towards the left side, and E2 is due to the positive charge, it is also towards the left side. So the total field is towards the left side. Total intensity E is points towards the left side because both intensities are towards the left side. So total field is E is equal to E1 plus E2. Mean E is equal to total field intensity is superposition principle, E1 plus E2. So E1 is lambda over 2 pi epsilon naught x from the minus Q, and the E2 is lambda over 2 pi epsilon naught D minus x from the plus Q, for the plus Q and for the minus Q. Okay, so this is first step is completed. We find the electric field intensity. Now we calculate potential difference by using formula V is equal to VB minus VA, which is equal to E dot dl. So we put the formula of E, that is lambda over 2 pi epsilon naught x plus lambda over 2 pi epsilon naught D minus x. So we took the constant terms outside the integration. These are the constant terms that we took outside the integration, and limit of integration is from R to D minus R. Limit of integration is from R to D minus R. So because limit of integration is from plus charge to minus charge, so R to D minus R. r to d minus r. Basically the limit of integration is from r to d minus r. Okay, now 1 over x, we use 1 over x plus 1 over d minus x. So 1 over x, so we took the integration separately, 1 over x dx and 1 over d minus x into dx. So this integration is log of x, this integration is log of d minus x. So we are left the log x minus log of d minus x, and we know that the x is equal to d minus r, x is equal to d minus r, and x is equal to d minus r, and d minus x is equal to we use the formula d minus x minus log of r minus log of r minus plus log. So we replace the upper integration, the lower integration, sorry, we use upper and lower integration. So upper integration is d minus r. So first we put d minus r, I solve here, log of lambda over 2 pi epsilon naught. So instead of x we put d minus r first, log of d minus r minus log of d minus r, and this minus will be plus. Okay, so this is upper limit minus lower limit minus lower limit. So lower limit is r, we put r. So log of r minus log of d minus r. Okay, so this negative and this negative will become positive, so we are left with the lambda over 2 pi epsilon naught log of d minus r minus d, and d will be cancelled, so we minus log of r. So this minus log of r again, and then this log of this minus plus, this negative and this negative become plus, so log of d minus r. So this is what here written, all the things. Okay, now we solve and we get log of d minus r. So log of r term will be one of the term will be cancelled or they are added. So log of d of minus r minus log of r minus log of r plus log of, so this term, these two terms will be added. So when they are added, so we have log of 2 pi epsilon naught, so we add 2 log of d minus r minus 2 log of r, and these two will be cancelled by the these two. So we are left this log of lambda over pi epsilon naught log of d minus r minus log of r. And now further we solve and we get log of d minus r. So now we put the supposition. Supposition is that d is very greater than the r, because we know that the wire has very smaller diameter. Wire has very smaller diameter. So that the diameter of wire is very small as compared to the distance between the two wires. The distance between the wires is very large. D is very large as compared to separation. So if d is greater than r, so d minus r becomes only d. D minus r becomes d. D minus r approximately equal to d, because r is very small. So small thing can be neglected. So d minus r is approximately equal to r. D minus r is equal to d. So we put the log of d minus log of r, and we use the formula for logarithm log of a minus log b. Log of a minus log of b, that is equal to log of a over b, and then we have log of d over r. And finally check. So we find the c is equal to k over v. So the v is here, k over pi epsilon naught l log of d over r. Now we took the reciprocal of all the things, we get pi epsilon naught l log of d over r divided by log of d over r. So the capacitance per unit length, so length can be taken to the other side with the capacitance. So c over l is equal to pi epsilon naught over log of dr. So this is the capacitance. So this formula shows that the capacitance per unit length depends on the d separation and the r distance, log of d and d over r. Okay, thank you.